the point of Git is to make this tracking less prone to human error, essentially. And then what it also allows you is to work on multiple ideas, multiple features, or try to fix multiple bugs at the same time. So there's this concept of branching in Git, where then let's say you have a solid base of code that you know is working, or you don't want it to stop working for someone else because maybe there's a little bug. You can branch off of that without making a full copy of that code, but just only keeping track of the changes and then merge back those changes. So we'll see that concretely in just a bit if that's still abstract. So in this workshop, we're talking about GitHub, but there's many different alternatives to GitHub. Some which are actually open source, which you may prefer for those particular reasons, because GitHub is commercial, is owned by Microsoft. And then there's other ones such as Bitbucket, SourceForge. But yeah, in this workshop, we'll look at GitHub mainly because yeah, it's one of the most used ones, and it's probably the more efficient way if you wanted to publicly share your code with other people. It's the platform that most people go to. So some of the reasons why or why not, as I mentioned, if you want something that's open source, depending on the features that they have. So GitHub, they add their own collaborative features on top of this Git protocol, which we'll take a look at. Maybe you would prefer some of those features over ones that are on GitLab, for instance. And other reasons, maybe, okay, you care about where the code is hosted if you want it in your country, and also the pricing on that particular tool. All right, so first thing to do, so if you have your laptops out already and you're going to be following along, is you can install Git on your computer. So if you're on this slide, you can press that link, and then you should be able to find the setup instructions for your OS. And then the second part, if you don't have one already, is to make an account on GitHub. So I'll let you do that for just 10 seconds while I just switch back to the slides for the people on Zoom, so then they can follow along. Let me figure out how to remove this. There we go. That's all right. I'll go ahead then. So one thing I do when I start a project, even if I don't necessarily plan on sharing it, which is what GitHub is useful for, is that I would start my project directly from GitHub itself. And the reason for that is because when you start a project, they walk you through these different steps, which essentially add some what we call boilerplate files to your project, which is files that you would want in any project, regardless of whether or not it's on Git or whether or not it's on GitHub or another place. So right now, what you can do if you want to follow along is you can go to GitHub, and what we'll do is we'll create a project from scratch and see some of those boilerplate files, which are quite handy to have in an initial project. So if you go to github.com, on the left-hand side, you can click on this new option in green, which will essentially take you to a menu, or let's say a little form to fill out to create a new repository. And repository or repo, as I'll use interchangeably, is just another way of saying your project files. And you'll hear people say repo to essentially mean their project. So what you can do is when you're there, if you have multiple, let's say, accounts, you can pick your account. You could give a meaningful name to your project. Here, I just took an auto-generated one from GitHub for demo purposes. And since this is a project which I don't really know what's going to be its purpose, and maybe it's a project that I'm just going to start, what I typically do when I start my project through GitHub is I just set it to private. So this is a free option that you have where you can just make it private, and only you or people that you're going to be working with will be able to see that code. And it's a nice way to share it through GitHub rather than WhatsApp, emails, or whatnot. In the next part, we see some of these boilerplate files, which I was mentioning. So the first is what we call a README. So it's essentially, as you see, it's in all caps. The point of this is to get the user's attention to say, okay, look at this file. This is where all the useful information about this project is stored. And what GitHub does is that when you go to your repo, so your project page, essentially your README will be on your home page of your project. So you can view it as a home page when you're starting to add stuff to your GitHub project. And it uses a specific language called Markdown, or you can use other TXT or other. The goal is to use just some sort of language or writing scheme that's easy for others to add to. So this is something I mentioned about a different file format you can use. So if you're going to add documentation later to your project, I would recommend using this RST format, but this we'll see in the Python part of the workshop. The next, okay, and this is the most useful part, I would say, when you start a project from GitHub, is adding a git ignore file. So what does a git ignore do? So I kind of give part of the answer here, but can someone add to this? What is the purpose of this git ignore? Yeah.
Unnecessarily push files in GitHub, which are only required for local purpose, or compiling or something like that.
Yeah, or what could be other examples? So you said compiled files, what else? Yeah.
That is not a Python file, maybe.
Yeah, maybe if you only want to make sure the project is Python files. What's another thing which can take a lot of space in the project? Okay, yeah, you don't want to push a virtual environment either. I'm thinking one thing that can take a lot of space, yeah? Data, yeah. Imagine if you have 100 gigabytes of data, you don't want to accidentally push that to GitHub, and I don't think GitHub will let you. So there's a limit, I think, on 2 gigabytes that your project can have. So you want to avoid pushing all of these large files, which can be generated from your code itself. For example, if you're working with C or C++, maybe, or even in Python, you'll have compiled versions where there's no need for you to push those files to GitHub because someone can use the source code to compile it themselves. So those are some examples of the unnecessary files. And the useful feature that GitHub provides here is that essentially for each language, whether it be Python, Java, C, C++, Rust, or whatnot, is they have templates for different git ignores. So you don't need to remember all the potential files that you'd want to ignore. You can just pick your language from the dropdown. And of course, GitHub won't know your data paths or whatnot, but then you can manually add those to these template git ignore files. So this is a really useful feature, which is why I typically start through GitHub to start my project, so that I don't have to think about, okay, what is the boilerplate git ignore to add to my project. The next really important part to add is a license. And this is strongly recommended because, for example, if you share your code, theoretically, no one should someone come trying to no one should you shouldn't use someone's code if there's no license attached to it, because you don't know what are the conditions for the use. And this is especially important if you're working in a company, because they don't want to use a license which then maybe requires them to open source code that they then use with that project. So usually you should be careful when also someone else doesn't publish a license. And what I would do in that case is just ask the author of that project, oh, can you add a license file to the code? And usually they're willing to do it. A really generic one that people use in research or academia is the MIT license, which pretty much lets you use the code essentially however you want. It has really minimal conditions. And if you don't know about choosing license, so I think GitHub, they link to this chooselicense.com page, which then helps you decide, okay, how do you help that, which lets you helps you decide, okay, how you want to choose your license so that you can share your code in a way that other people can use it as you want. So yeah, then once you've set all those different parameters, so license, git ignore, readme, all those boilerplate stuff, then you can go ahead and press that create repo button. Any questions on some of those options? All right, so yeah, when you press the button, essentially it'll take you to your brand new repo. As we can see, it's private, and it has those 3 files that we initialized. And the README was just initialized with the title, which is why we just see this upgraded potato. But then we can edit that file directly from GitHub, which is another nice feature that add this graphical way to edit files. Okay, so now you made this project, but it's not on my computer yet. It's still in this cloud, in this remote server. So the next step would be, okay, I want to download this locally so then I can, within this project, start coding my application or my project. So on this right side, this code button, there's a drop down with which you can select different approaches for downloading the code of this project. So we're going to look at a few ways, easy way, the intermediate way, and maybe I think that's it. But because it's good to know these different ways depending on what computer you're working with, or if you have, let's say, a screen or not. So the graphical way is to use an application that GitHub themselves provide, which is called GitHub Desktop. So you can find this download link. Unfortunately, it's only available for Windows or Mac OS. I think older versions of it are available on Linux. So that's one option. And then when you go to that dropdown, there'll be this, one of those options was open with GitHub Desktop. So you can click on that and then it'll redirect you to your local application to then download the code locally. The way that I recommend, because it's going to link well with the part 2 of the workshop, and especially for coding in Python or even other languages, is to use an IDE for managing your source control and managing your repos. So who of you already used an IDE? Okay, cool. So hopefully you've already seen how it simplifies a lot of your development workflow, and source control is usually one key component of a lot of IDEs, including Visual Studio. So, and this is a small word in other IDEs. So other ones that could be common are PyCharm if you're working in Python, Replit if you want something more browser-based, or Spider, which is more popular, I guess, in academia and research. Yeah, I go for VS Code. I started with PyCharm, but their free version, on which, okay, if you're a university student, you can get the free version, didn't allow remote development. So what that means is being able to connect to a remote server to code on that as if it was on your computer. So that's what made me switch to VS Code. And then VS Code has a bunch of really cool plugins. But PyCharm is also great. And if you're at the hackathon, JetBrains, who develops PyCharm and other IDs, will be at the hackathon to give some tutorials on that. But yeah, for this workshop, this part and part 2, we'll look at VS Code. So here are just some reasons why you want IDE syntax highlighting. It makes these link between different files, so you don't need to kind of keep track of all your different files. And if you wanted to change a variable in one file, you'll change it everywhere else. So a lot of useful features, one of them being source control, as we'll see in a bit. So yeah, one recurring slide I have is here. Don't make your life complicated. Get an IDE. I know some of you who there uses Vim in the audience. Okay, I thought you would. You're pretty cool for doing that, but you're making your life too complicated. Also, don't do that. Use an IDE if you can. It'll make your life simpler. Sometimes Vim is useful, especially if you only have a command line interface. Okay, so then info from VS Code. So if you've downloaded it, you can open it up. And if you followed along and if you made your GitHub repo, there's this option when you go to the homepage of clone Git repository. So you would go ahead, click on that. You can pick one of these two options, either clone from URL or clone from GitHub. If you do from URL, it just means that you need to copy and paste the URL of your repo into that top search bar. And then it'll ask you some questions about where you would like to store it. So usually what I do locally is I make a GitHub folder and I have all my projects in there. And then it's going to ask if you want to open it right away, which, yeah, we'll do in this case. So yeah, open the repo. I'll let some of you do that. Are there any questions on that approach of, because it's also graphical like GitHub Desktop. And what I prefer about this is that it's the same environment where you'll be coding, because you can't edit the files on GitHub Desktop. It's only going to be for doing source control. So it's kind of annoying to have to need two applications when you can just have one to do both coding and source control, which is why I would recommend something like an IDE. So no questions. All right. Intermediate way. So sometimes maybe you're forced to use a command line. So this could be intermediate to hard, depending on your knowledge of the command line. For example, if you're working on a Raspberry Pi, which you don't have a screen, or you're connected to a server which doesn't have a screen, it's useful to know what are the command line commands that you would run on the command line to be able to clone a repo and to navigate it. So for that option, it's the same dropdown. When you go to that code dropdown, they give two options for downloading it through the command line, either through HTTPS or SSH. Reasons why you might want to use one or the other. So SSH is more secure. You can also then, if you're working with private repos, be able to download them without having to enter your password each time. And I think at one point, GitHub is going to stop support for HTTPS. At least it's not as convenient as using SSH. But what's just annoying for SSH is that there is a first setup, which is typically is not obvious, and especially if you're not used to the concept of SSH. And so the point of the next few slides, I'll just show you how you can set up this SSH, and it only has to be done once per machine. And then it allows you to use this protocol with all repos for that particular machine, private and public ones. So who's already made a public private SSH key pair before? Just get an idea. Okay, so we'll see that in just a bit. Hopefully it's clear. So okay, once you've made the pair, essentially you would copy that command line like this. So this is what I was saying. There's this first time setup, which is to create that pair. You'd have to copy the public key. It's important. Copy the public key to GitHub, and then you can clone like this any of your repos, private or public. So to generate the secret public key, so GitHub, they provide some nice documentation for this. So when you go to this link, so it'll take you to a page that looks like this, and it should detect which OS you're on. So for example, I'm here on a Mac, and then essentially you follow these steps, and it's going to give you some commands to run through the command line to create this private public key pair. So you need these two keys, secret private or secret public are some of the terms we use. And then what you want to do is to copy the public key, important, copy the public key. So this is how you could do it through the command line for the different OSs. And then you'll take those copied contents. And what we need to do is we need to share that public key to GitHub. Because essentially the way that SSH works is that it's going to use my private key and this public key, and it's going to do some operations between them to make sure that I have access to this repository so that I can download it. And in that way, once I've set up this public key that's on GitHub and the private key that's with me, I don't need to ever type my password again, because it's going to use these two keys to compare with each other. So then to share this public key to GitHub, so you'd go to the GitHub website, you go to the dropdown for your profile, and under settings, you would go to SSH and GPG keys, click on new SSH key, and then here you would just give a name for that key. It could be my laptop, let's say remote server lab 1, lab 2, lab 3, or whatnot. And you would copy the contents of the public key into this text box here, and then press add SSH key. All right. It's good to, I'd recommend taking maybe a minute to try to go through those steps, because this public private key is something that's useful not just for GitHub, but also if you wanted to SSH to like, let's say your labs or a company's server. Usually they would probably want you to go through this process of making a private public key to authenticate you. Sometimes people rely on password, but the recommended approach is SSH key. You have a question? Yeah. Sure. So the steps are on slide. I should have slide numbers. So if you go to slide, let's see what it is. Number. Slide number 34. So there, if you follow this link to GitHub, essentially it'll detect your OS. And then these are the steps for generating this SSH key pair. So essentially, the steps are: you open your terminal, you copy this line, replacing your email, of course. And then this is what will actually create the key pair. It'll ask you if you want to add a password to the key pair. You don't need to do that. And then it will, so that's where it will ask you for password. And then it will create the key. Yeah.
Is it already the same email that the one we used to sign up?
I think so. I never tried with a different one, but it's better to keep the same one. Yeah.
Actually, email is just another way to authenticate. Like you don't need an email to get to the like you actually don't need an email.
Yeah, so there's a question from the person on Zoom. Do we have multiple private public key pairs for different applications? For example, GitHub, GitLab. You can, but you don't necessarily need it. Because the idea is that storing your private keys are already so secure, and the public key is really for the public. Like even if a hacker gets it, it's fine. because with the private, you really need the combination of the private public key to really be able to hack or to break into a system. So yeah, I don't know if you have another Adrien, if you have another advice. You theoretically you can use the same pair.
I guess good practice is to use different pair each time, but
Okay, maybe better practice to have different pairs, but it's not needed. I mean, that's
it's not really good. I
Yeah.
mean, just like you said, SSH is already such a secure protocol. It's fine, I guess.
until we have quantum, but yeah.
Yeah, obviously. The only thing to be careful about, if you have multiple SSH keys, you need to make a SSH config file to tell SSH which SSH key to use on which
Yeah,
private key bus.
Things get a bit more, but yeah, that's not needed for the workshop, but yeah. If you have multiple, then it could get more complicated, your setup for authenticating with different applications. But for now, I think using the same one is fine. And essentially it will create this key pair, usually in your home folder in a .ssh folder. And the key will end in .pub, like you see here. So actually here you can see example paths. So on Mac OS, it'll look like that, Windows, Linux, and you want to copy the contents of the file that ends in .pub. All right, so any other questions? This is kind of tangential to Git, but it's still quite a useful concept to be familiar with. All right. And that means, yeah, I would recommend that when you clone repos, really to pick the SSH option, which means that you need to go through this first step of installing these keys, but it's going to save you a lot of hassle of Git not being happy, of you not using the right protocol. Because sometimes it will allow you to clone with HTTP, but it won't let you push with HTTP. So I never understand why they don't let you push or when they don't let you push, but it's just safer to just stick with SSH and just go through that quote unquote pain of setting it up in the first place. All right. So let's move on from here unless there's any questions. All right. So now let's look to actually, okay, we've made a repo, we've downloaded locally. Let's now make some changes to the code and push those. So that's what we call so uploading. Another term for that in the Git, or the term we would use, is push, to push our code. So there's multiple steps, let's say, in this workflow of, okay, adding files to your GitHub repo or to share them eventually. So the first step, of course, I mean, this is irrespective of GitHub, is okay, you're going to be making some changes to your code, maybe make some new files, you delete some files, you change some. And then there's this 3-step process for Git, where you first add those changes, whether they're new, changed, or deleted files, you commit them. So it's essentially giving like a tag to those changes, and then we're going to push them. So we're going to synchronize it with this remote repository. We'll see those steps multiple times, so hopefully it gets into your mind. So for example, so I have this really basic file, so you can also make it like this if you've cloned it locally. So I made a Python script where I just write kind of a simple hello world, my name is. So this is I have these 3 files, or 4 files now, because remember we made those 3, the git ignore, the license, the readme, and now I made this 4th file, which is already in the repo. So that's why, so we have this one, which is hello world, my name is Eric, how are you? So this is my file before any changes. And now this is my file after changes. Now a question for you. How many changes were made to the repo? Raise your hand if you think you have it. Yeah? Okay, what changes? So there's this new file and a modification. Anyone see something else? Yeah? Yeah, so these are the changes I made in the Python file. So how many changes did I make in the Python file? 2. So there's the lowercase here, and what else? A comma. So what Git will see, Git just sees this as one change because it's happening on one line of code. So that's one change. The other change that we saw was there's this new file. Does anyone see something else? Not you? This is a tricky one. Yeah. Yes. So the README got deleted actually. So it's not missing. So actually, the answer was on the slide for you if you're familiar with VS Code. So the answer was right here. There's 3 changes. So now we're gonna see some of the conveniences of using an IDE. So what we have here is what the IDE will have is on this first, let's say, icon, we have all our code, which is what we're reviewing here. If we click on this, I think it should go to the next slide. Yeah, it will now show you all the changes that happened since the last commit message. So as we all put together, there's this new file that was created, Python, where there was 1 line that was changed, but we can see these 2 parts that were changed, and then the README that was deleted. So this is the really, really useful part of an IDE. So on top of Git keeping track of things, the IDE is now visualizing, okay, what are those actual changes? So it's going to use, I think I have it here, green if there's a new file, yellow if there was a modification, and red if a file was deleted. And similarly, within specific lines of code, we'll see this line is highlighted in red because it considers that, okay, this line was deleted, and then we added a new line, which is why it's in green, and then it highlights the characters that are the ones that changed. So this highlighting really helps you now to see, okay, what changes were made from before and now what you changed now. And then you can click on the individual files then to see what actually changed in that file as well too. Any questions on this? Yeah.
What is it?
U it stands for untracked. So there's this terminology in Git which is tracking the files. And since it's a new file, it hasn't been tracked, so it labels this as untracked, which is kind of a way of saying new as well too. Any other questions? All right, so hopefully this is another convincing argument for why an IDE is useful. Okay, and I forgot to mention one part. So there's this kind of arrow, which is kind of curved, where if you didn't like a specific change, you can then undo the changes in that file. And I think you can do a similar thing for specific lines of code. If there was a specific line that you think, okay, that was a mistake, I should have kept it as it was before. All right. So we saw this first part now, which was making edits. We made edits. Now we were able to visualize these edits from the IDE. The next part is now adding these changes. So on the IDE itself, when we're in the source control icon, there's this plus button, which is essentially what's the Git term is staging these changes now, or adding these changes. So essentially, when you're here, you don't need to change. You don't need to add all of the things that were changed. Maybe, for example, the new file, you still need to make some changes to this. It's not ready, so you can maybe only want to add the modifications you made there. And yeah, so we're going to add that file. And then when we add that file, it'll come up now in this new category. So before we just had changes. Now these are staged changes. So these are changes that we're saying, that we're telling Git that, okay, we're ready to now incorporate this into the tracked changes. So python.py has been added to there. And when it's there, we call it to be staged. And then if you want to, similarly, if you want to undo changes, you can also undo staging. So if you realize, okay, actually, I still need to make changes to this file, you can press on that minus sign to then unstage it, make your changes, and then again stage it. Any questions on that bit? A lot of terminology here, but through practice, it becomes more intuitive. All right. Okay, so we've done the second step now, which was staging or adding these modifications. Now we're going to commit these files. So committing is essentially now in the top part of this source control pane, there's a little text box where we can now describe those changes that we made. And this is good practice so that when we look at the history of changes, we can go back to a specific one. Like maybe we realize, okay, there was a bug that was introduced in python.py. And it's good maybe in that message to say, okay, I updated the print message in python.py so that we can go back to that commit message, that commit tag, to then understand, okay, how we introduced the bug. Because essentially when we look at the history, we'll see this message. So if you don't have a useful message, then you may not know where to search for the errors that happened. So to make that a bit more concrete, so let's say if I go to my GitHub repo, you can see the history of a repo by clicking on this button here. So here there's been 25 commits. I don't think I made them very meaningful messages, but here you can see all of the commit messages that I had. So for example, you can see maybe I made the greeting more energetic there and I wanted to change. I realized that was an issue. So that's why it's good to have a useful message associated with the changes so that you can go back in your history to then fix any errors that you may have unknowingly introduced. Let me just close this one. Okay. So that's the concept of committing. Any questions on that? Seems a bit, I know it can seem a bit unnecessary because you're adding all these different steps just to be able to want to drag and drop a file into a folder. But this is what this method is what lets you have trackable changes essentially in your project. All right. Maybe you can try along if you've made a Git repo locally, or you can try later on with the slides. So after we've committed it, now we won't see that staged thing anymore, but it'll go down to something called outgoing, where now these are commits that we made that are now ready to be pushed or ready to be uploaded to GitHub. And then in the bottom of that pane, we can see there's these different arrows, one that's going up, one that's going down. So here, this arrow that's going up, there's a 1 associated with it to say essentially that, okay, there's one change that can be committed to the remote repo, so to GitHub, where we've stored the code, and there's nothing necessarily to pull. So to push now our changes, and you can have multiple commits before you push. So maybe we did 2, 3, or 5 multiple commits, and then we can push all those commits at once. And those changes won't be on GitHub until you do this push. So there's the commits, which is everything is still happening locally, and the push is now uploading those changes to GitHub. So by clicking that essentially synchronize button, you'd be pushing your changes through VS Code. And then it'll ask you to be sure that you want to do this. Okay. And then you'll still see the changes because those things were not committed. So that's why after pushing, this outgoing will be gone, but you'll still see those files that have changed because we haven't committed them. We haven't added them. We haven't committed them. And so that means when we pushed, none of those changes went to GitHub. So if you were still working on those files, your colleagues wouldn't see them, which maybe you wouldn't want if you're still working on them and if they're a work in progress. So any questions on those 3 steps? Add, commit, push. Yeah, back there first.
Yeah, so why, like, what's the logic of having these 3 steps? And why don't you only have 2 or 1?
So which one would you get rid of?
Maybe the stage and the
Okay. Because I guess in this case here, how do we had 3 files that changed. Maybe we don't want to stage and commit all those files. So the point of the add is just to select which ones you want, essentially, without having to undo the changes there, because maybe there's some changes that you're still working with that. So that's why it's good to separate the add and the commit. Yeah. You had a question down here?
I did the outgoing paragraph on my VS Code, so do we have to do something to?
So you don't see it?
I don't see that.
Okay, so maybe we can see it later, but do you see the numbers? Okay, so I think it happens sometimes, it depends on your settings, but you can still press that synchronize to push the changes. Probably I think if you go on the drop, is somewhere around here, you can see the history, which may show out, you can visualize the outgoing. Yeah. Any other questions? All right. So to give you the command line version of things, because maybe you're in that context, the commands I find myself often using are git status. So essentially that's what's going to show the changes with those similar UDM. Git diff if you want to look at the differences for all the files, or you can put git diff python.py if you want to look for a specific file. And then that 3-step process is, the names essentially translate to the commands. Git add the file, git commit, and then you write the message after this command line argument, and then git push. And if you want to restore changes, that arrow that we saw on VS Code, it's git restore the file. Yeah, we'll skip through those because those are, maybe you have more time, unless there's a question there on the command. Is it more what? Convenient? Yeah. I mean, generally it's more convenient. Also, in terms of visualization, it's helpful. It's more convenient to visualize the changes through VS Code than through the command line. Yeah. Your question? Yeah.
All these commands, like, do we need to like really memorize and drill all these things?
No.
No, I mean, for example, in Vim and
Yeah.
it's somehow more intuitive in the sense that it's close to the language, like verb and this kind of stuff. Isn't it? Is it like this, or is it something that we practice more and then we're gonna take it up somehow?
Yeah, I guess I'll answer your last question, which I think answered. So I guess the question to repeat on Zoom is, are these commands that we really need to memorize? No, we don't. I mean, there's a lot of other Git commands which I don't know by heart. And when you're ever stuck on something, Google or nowadays ChatGPT, your favorite LM will give you your answer. Like, okay, how do I push a file? What's this? What are the commands? And then you can also find these Git cheat sheets if you need. But also, as you were saying, through practice, essentially, eventually you get used to them. Like these are the ones I know by heart because I've just used them so many times. But then the ones where I need to, let's say, go back 2 changes or revert some stuff, I never remember those. But then what's more important, I think this is like a notion in engineering in general, is knowing where to find the information rather than knowing it itself. That's usually more important. So as long as you know where to get the information, that's the more important bit. Maybe these slides, if you like them a lot. But yeah. Any other questions? Yep, back. You mean here, commit? So I mean, unless if you don't have anything staged, like if you didn't press plus on some things, there's nothing to commit, so you wouldn't be able to commit. So there's multiple buttons that you need to press through the IDE. Yeah, maybe that wasn't your question. You had another question, or okay. All right. Need to take some picture. All right, so that's a bit some of the overview. So these are the bit, but the Git basics essentially, and how would you use it through an IDE, through the command line. Now let's look at the GitHub side of things. So what does GitHub add to this story, to this workflow? So I'm just gonna, if we go back to my upgraded potato repo, so there's different tabs that you may have seen there. So I'm just gonna give you a walkthrough of what are the uses of those different tabs. So the code is the one that most people by default go to. Another common one is what's called issues, which is a terrible name because it makes it seem like there's a problem with your code. But usually people use this tab to talk about, okay, what could be nice features or suggestions. And I wish they would change the name because sometimes I feel like people are a bit reticent to open an issue because they're afraid to tell the code developer, oh, there's an issue with your code. But this is essentially where you keep track of bugs, which are real issues, but also ideas. And there's not necessarily, usually there's no code associated with issues. You just kind of put an idea, oh, it'd be nice to have this. And you have like a forum where you can talk about different ideas and bugs. Pull requests is where you would actually try to offer new code to the project. And this is what I would strongly recommend when you're working with collaborators to use this this mechanism to add new code into the main code, which is what you see on this code branch. And we'll get to branches in just a bit, but pull requests are ways that people can contribute code to a project. And one way you can kind of make changes to a code without affecting the stable code is by making a branch. So by default, Git will have what's called the main branch, which is what, as you can imagine, has the main code. But you can make a copy, I'll put in quotes, a copy of the main branch of the main code by making a branch. And the reason why I put in quotes is because it's not really a copy. It's rather a pointer that's just going to use the Git protocol to keep track of the changes. So similar to how we saw in the previous file, we just changed one line. I mean, the code was also one line. Imagine we had 100 lines and we only changed one line. The branch is only going to keep track of those lines that change. It's not going to make a whole copy of the code because that would then bloat or add unnecessary content to your branch that don't need to be there. What you only really need to keep in track of is the differences, which is what Git is doing. So you can create a branch by essentially typing a branch name through GitHub, and then maybe I'll show it from GitHub itself. So let's say I wanted to create a branch like workshop 2024. So it doesn't exist. So then I could create that branch like this. And then it would open, it would bring me to a new window where I'm in this branch rather than in the main branch. All right. Our next part is in the landscape of a GitHub page is what's known as the fork. So this is what's actually going to not physically, but digitally copy your code. Branches, we're not making copies. They're just keeping track of changes. Fork is going to make a copy on someone else's account. So for now, this project is under my username. The reason someone would want to use a fork is, for example, if you're someone random person on the internet says, oh, your code is really cool. Can I make some changes? Maybe you're not going to give them access to your version of it, but you would ask them to fork it so they have a version on their account, and then they can make a pull request to then add changes. And then when you start to trust them a bit more, or then you can maybe add them as a collaborator, which we'll see in a bit. But fork is making an actual copy, branch isn't. Any questions on those different parts? Again, a lot of terminology. Yeah.
Isn't it more complicated if you say, like this scenario you just explained, if someone did a fork and then wants to do a pull request because it like might diverge more?
Yeah. So there's ways that you can synchronize the fork still. So that's another really neat feature of GitHub. Let me see if I have a fork which I can show that. Where did I make the fork? Maybe I made it under LauzHack accounts. Let's go to see here if I have. So yeah, here's a fork that I made to show you this. So I'm on the main branch of my fork, which is, since it's a copy, now it's a different repo altogether from the original upgraded potato. But GitHub detected, okay, there's 13 changes between your fork and the original upgraded potato. So before I would make a pull request, I would do this synchronized fork option, which would update my fork so that now when I make changes, I can make sure I have all the new changes before making that pull request. Yeah. So yeah, GitHub has all these nice little things that they thought about which make it convenient. Yeah. We'll get to that more deeper in a bit, but the idea is you made a branch, you want to merge different parts of code together. And a pull request is a GitHub term, which helps you visualize those changes to then talk about them. So we'll see that. So that's really the collaborative feature, which we'll see in a bit. Yes. Any other questions? All right. Okay, so I think in this part we should see. Okay, not just yet. It's okay. Let's say we're on this private repo and now you wanted to add some collaborators. So people you trust in this case who you're not asking to make a fork. You would go to the settings option, collaborators, and then you would add the username essentially of those collaborators that you want to give admin maintainer access to the repo. Okay. So before looking at pull request, we're going to look at merge conflicts. So how many of you have faced a merge conflict before and just said, this is too complicated for me? And okay, so I'm going to try to do a very dumb example to hopefully make it clear and also to show why using an IDE makes it a lot more convenient to deal when these type of situations arise. Because it will happen when you work with code that even more than one person is going to work on. So it can even happen when you're working with yourself. That's happened to me before. Don't ask me how, I don't remember how, but we'll see. I'm going to make one by myself now, so you'll see how it's done. Okay, so to give you the context, I have two versions of this repo on my computer. Upgraded potato v1, upgraded potato v2. And merge conflicts happen under two situations. When people make different changes to the same line or lines of a file, or when someone edits a file when another person deletes it. And what happens is Git doesn't know how to So Git can figure out a lot of changes, especially when they're on different lines. So it will automatically do it for you. So you don't need to figure out how you bring your two different code bases together. But when two of you change the same line, there's no way for the protocol to know who is right in this context. So this is where we need human intervention to solve this. All right. So in my example, so from upgraded potato v1, I've made a change. So maybe you noticed I have Lilo and Stitch images in my slides. So Lilo has v1, Stitch has v2. Lilo said, okay, my name isn't Eric. I'm going to make it, hello, my name is Lilo. She follows the process, add, commit, push. All right. So she's pushed it already. It's out there. Before it said, hello, my name is Eric. Okay. Stitch is on v2, working on his own version. And he says, or it says, my name isn't Eric either. My name is Stitch. So I'm going to change that line as well and change it to my name is Stitch. And now Stitch tries to push the code. Now we're going to get a conflict because two people remotely, there's this change. When Stitch tries to push it, the Git protocol or GitHub is sending that message to say that you can't push this. Someone has already edited this file line. Now you need to figure out who's right in this context, essentially. Yeah.
But you said you have two versions. Is it two branches?
No, so here they're on the same branch. They're locally on, they locally have the repo and they're both on main and they're both making changes on main. So when you make a clone or when you fork, you're always going to copy the main branch. And so this is also showing an example of why it's not good to work on the main branch, but why to branch out. So both of them are working on the main branch, on the same branch, and then they get this conflict. Because if you're working on different branches, you wouldn't get this conflict.
Even after merge?
Even after. So if they're on different branches, so if they merge, there could be conflict. Yeah. If Stitch merged, if Lilo made a branch and merged it into main, and now Stitch tries to push to main, they will have an issue because it's just seen as a change on main, and Stitch is just working on main. But if Stitch was working in another branch, you wouldn't have that issue. But then if you want to merge in the pull request, then there would be a conflict. So it's really okay when you're on the same branch, same file. I could add that. All right. So this is the nice part of VS Code. Now it's going to visualize this conflict for you, this merge conflict. So essentially we have these two lines of the same codes for some reason where it says, hello world, my name is Stitch. Hello world, my name is Lilo. And what's being presented to us by this IDE is the change I made. So it's what they call the current change and the change that is remote. So that's why it has this long tag. Essentially, it's given to it this hash or this tag. So we saw this commit message, which is associated with this tag. So we now see Lilo's change, and essentially we have a conflict because we both tried to edit the same line. And what's nice with VS Code is that they give you when you click on this file, so here it will show you which are the ones that are conflicting. You'll have some graphical ways to resolve these conflicts. So when I click on that file, I'll now see this menu appear on the top in gray. So either I can say I take the current change, so I take what Stitch wrote, I take the incoming change, I take what Lilo wrote, sorry, or let's say I take both, which is going to put one line on top of the other because maybe I want to use parts of both of them. So let's say I take, because essentially what needs to be done under this merge conflict is that these tags need to be removed. And that's how Git is recognizing that there's a conflict. So these tags need to be removed. And when you press on one of those options, it'll remove them. So in this case, what I did was I said accept both changes. And then I manually edit things. And then I made it something kind of a hybrid of the two. Hello, Lilo, my name is Stitch. Because Lilo made a change, so I'm going to say hi from Stitch. So now the tags are gone. And when the tags are gone, now we can go through that same process of add, commit, push. But before I show those again, are there any questions here? Yeah.
When you have a merging issue at the first modification, when you say, okay, my name is Lilo and I'm Eric,
So why didn't Lilo get an issue? Because she was already synchronized with main. So when she made the change, she had the same version of the code that was on the main repo. And then she added a new commit. Remember, we saw those 25 commits in history. So Lilo has all those 25, and now she's adding a new one. So it's no issue. There's no conflict. But essentially, when Lilo added, let's say the 26th one in this case, Lilo's only, or Stitch is only working with 25. So when he tries to push, he doesn't have the full history that he should have before being able to push. So what will happen in this case is Stitch will now, when we do this merge, Stitch will now get Lilo's commits and he'll add a new one, which is this one that's been auto-generated here, merging these two. Any other questions? Yeah.
I recently had the issue like merging Jupyter notebooks.
Yeah.
And there was a lot of code which I could make any meaningful decision.
Yeah.
I ended up figuring it out, but just by luck.
So yeah, Jupyter notebooks are a pain. So I'm not going to say it, but if you come to the part 2 of the workshop, I'll give my philosophy on Jupyter notebooks. So, but if you want to use Jupyter notebooks, which I guess you can guess that I wouldn't, don't push the cell outputs with it. So unless you really want to make it a demo with plots, what I would use a Jupyter notebook for is really, okay, I want to make like a nice demo thing. I wouldn't use Jupyter notebooks for development because they introduce all sorts of bugs and stuff. But I'll leave the Jupyter notebook discussion to the Python workshop. Yeah. Question? Yeah, let's leave, because let's try to focus on GitHub. But yeah, we'll talk about Jupyter notebooks a bit in 2 weeks. Yeah.
Lilo made the commit even if the changes are in the same line, but Lilo is backing the commits. Will there be a conflict?
So Lilo didn't get any conflict because she was up to date with Mania. Stitch. Yeah.
There are 25 commits, but
Yeah.
Stitch is like on 13, but the
Yeah.
modifications it made is like non-conflicting with the.
And then Git will figure it out. And yeah. So in that case, what it'll do, it'll pull those and then add Stitches as the most recent one.
But you
Yeah. No, you don't need to. So that's why Git is so convenient, is that on the stuff where there's no conflict, it'll handle it. But for these where people change the same line, there's no way you can know which one you should take or not. Yeah. All right. So we resolve the conflict. Let me just see if there's any question on. Oh, there was some on. Okay, sorry, I need to go. Okay, hopefully they didn't have any. All right, so now we'll get to pull requests. So what Marco was mentioning. So this is one way that we can. So as we talked about, it's best not to work directly in the main, but to make branches. And then from those branches or from those forks, we can make pull requests into the main to help detect these potential conflicts, but also as a convenient way to talk about code and to collaborate on the code itself. So we saw one way to make a branch, which was from GitHub. You can also do it from VS Code. So you'll see on the bottom left the name of the current branch that you're working on. You can click on that and then create a new branch, type the name, and then create a new branch. So now, after you've done it, you'll be now directly on to that new branch where then you can make your changes. So here, since we were using that previous code example, essentially here I just made a branch from main, which had that merged solution, which was hello Stitch, hello Lilo, my name is Stitch. And then now I can make some different changes now. Let's say I wanted to make the greeting more energetic. So I say, hey, Lilo, like with an exclamation mark. Then I add, commit, push, same process. But what VS Code will detect now is that, okay, this branch doesn't exist. So if you made a new branch locally, this branch doesn't exist on GitHub. So it's going to give you another option, which is rather publish branch to publish it remotely to GitHub. And then one of these other little features, so now if we switch to GitHub, one of these other little features that GitHub makes to make your life easier is that when you go to your repo page, GitHub will detect, oh, there's been a new branch that's created. Do you want to compare the files in this branch with the main and make a pull request? So probably yeah. So we're gonna press that green button. And essentially, when you open a pull request, you'll see few main features. One is this is the new branch that I want to merge into main. The good thing is to add some sort of title to describe what these changes are about. And you can add some more description here. You can add plots, other discussions. And then you could go ahead and press create pull request. So now we've created this create pull request. So that would appear on, I think you may already, so I'll go back to the main one. So here we can see there's 3 pull requests. So here I had different ones that I made for different versions of this workshop. Make message kinder. Here we're making a more energetic one. So yeah, that's where you would find your pull request. And here we can see how many commits have been made. So you can have multiple commits for a pull request, and then how many files were changed. And then let's say we added this collaborator that we had. We can add them as a reviewer to now look at the changes that we've made. So here, I'll add Louis, who I added as a collaborator. And so now this is the part which for me gets really interesting, especially when you're working with a lot of files, many different features. So when you go to this files change tab, you'll see a whole list of files, and the list of files will be there, and then the change files will be here. And what's super convenient is that on a specific line, so here it's kind of a stupid example, there's only one line. So there's this plus button where I can leave a comment on that specific line. So maybe you probably had this experience where you've shared your files with someone, maybe over WhatsApp or Telegram, and you say, hey, can you look at this function? Do you think I'm doing it correct here? What's really nice about this feature in GitHub is now instead of trying to describe as detailed as possible which line in the function they should look at, you can literally put a comment on that function, on that line in that function, to then have a discussion. Okay, is this the right way of doing something? And then you can chat about it there and then make changes as needed. So this is the part on the code review, collaborative coding that I find super interesting with GitHub. Any questions on that before I go on to the next part? Yeah, so this is a GitHub specific thing. You may find it on other platforms, but GitHub does a nice way of you can have as many threads as lines of code there are. So you can have multiple discussions so that you don't need to have a WhatsApp or an email thread where you're trying to remember, okay, which part of the code should I look at here? All the discussion is really tied to the code itself. And let's say during a discussion, you had to make many changes and you ended up having hundreds of commits. Okay, that's an exaggeration. Maybe you had 20 commits. Maybe also you didn't take the time to write nice commit messages. You just like update code, update code, update code. Who's done that before? I'm sure many of you have done that. So another nice feature of the pull request. So the idea is to make these pull requests light, really make it associated to one feature. I don't always do this, but this is recommended. So let's say you had a bunch of these update code, update code, update code. This nice thing about pull requests is now you can take all those update codes and merge it into a single commit where you just say, okay, I fixed this particular function. So that's when you're happy, let's say with your pull request, that's what you'll see in the bottom where there'll be this merge option. And the one I usually pick is I go on this drop down and I pick squash and merge. So it's going to, in this case, it's going to squash all those 3 commits or all those 10 or all those 100 commits into a single one so that you don't have this nasty Git history of update code, update code, but really meaningful commit messages when we look at those 25 or however commits you have. Any questions on the squashing part? Yeah, this is what helps to kind of keep a clean code base as well too. Yeah.
Right. When you merge a branch,
Yeah.
you have to recreate this branch after this.
So it depends. So when you merge a branch, see if I can do it here with one of them. Okay, there's a conflict on this one. There'll probably be a conflict here. So when you merge it, there'll be an option where it says, do you want to delete this branch or not? So you can delete it right away in case you don't want to have like 100 branches to your code, or you can decide to keep it still. But it will always exist locally, even if you delete it remotely. You have to delete it both locally and remotely if you want to go away completely. Yeah.
Okay, so if I delete it locally and then push it, it will still be online.
If you delete it locally, maybe there's a way you can delete you can push deleted branches, but I'm not entirely sure of that. For sure, what I would do is just deleting them from GitHub itself, because that's like the public space that you're sharing with people. So it's good to kind of avoid having a drop down of 100 branches. Any other questions? So hopefully you find this feature of GitHub to be quite interesting. I even use it with myself, honestly. Like if I'm working on different ideas, I'll make a branch and a pull request for different aspects of the project. So I don't need to kind of have this huge mental model of, okay, which branch is doing what and copying code in different places. I really use GitHub as a way to kind of plan out my project and plan out the different features that I'm working on at the same time. Okay, so if you were not a collaborator, so in this case, we made a pull request from a branch. The workflow would be, as we saw, would be for you, let's say you want to contribute to TensorFlow or PyTorch or one of these big libraries, and I don't think Facebook or Google is going to give you collaborator access. What you would do is you would create a fork, so you would copy that code base to your account. This part I strongly recommend is you keep the main branch without any changes. Because remember we saw that sync main option? Because if you make changes and you try to sync, you can get into conflict. So keep the main clean, but make a branch from main where you then do your changes. And then clone your fork, which is downloading this code locally, go to that branch, and then make a PR not from the main of your fork, but from the branch of your fork. A lot of terms there. Let me give the example from here. Let's see if I still have it. Okay, so here I'm on my fork. Instead of making changes directly in main, pushing changes here, because if I do that, I may have a problem here, because it may say 13 commits behind and 2 ahead, and I may have conflicts with the main branch of the original upgraded potato. So the idea of making a branch is that this sync fork will always be without conflicts. I just can synchronize it. And then the idea is that I make another branch, let's say dev where I make my changes here, and then I do what I usually do, but maybe it's a bit overkill, but I do it just to be sure I avoid conflicts, is first I synchronize my main. So sync fork, update branch. So now it's up to date. And then from dev, I merge the changes from main into dev. So that I can deal with those conflicts on my side rather than asking PyTorch or TensorFlow to deal with those conflicts, so that it's easier for them to integrate my code, so they don't see any conflicts in the pull request process. That's kind of the idea behind it. All right, any questions on that workflow? Yeah, this will come with practice. Yeah, hopefully this outlines the various steps. All right, okay, here, here's a visual of the steps. Forking, making a branch, cloning it, as we saw, we can do it from VS Code, switching to the branch from VS Code, synchronizing main branch, as we saw, and then synchronizing with synchronize your main branch and the main into your development branch. Yeah.
You have to change if the repository is a public one.
Yeah.
And when I fork it, we have to change manually the private the public to private. Sorry.
Wait just a second. I have a pizza calling me. Can you repeat the question? Sorry.
When the repository is a public one.
Yeah.
And I want to fork it. I don't know.
Yeah.
You have to change manually prior to the public to private.
You want to make a public repo private. I'm not sure if you can do that. If you can make maybe the other way doesn't work. You can't make a private one public, but maybe you can make a public one. So the way you would check those settings is when you go here, there's something under visibility. Change repo visibility. Here it says, for security reasons, you cannot change the visibility of a fork. So if you fork something, you can't change it. You can't change it, actually. Yeah.
So the owner of the first repository.
Yeah.
Can see by on phone.
So if it's private, maybe if it's private, maybe not. But if it's a public one, yeah, I mean, yeah, your fork has to be public if you make a fork of a public repo. I mean, the workaround for that is you manually download the code, you create a repo from scratch in GitHub and push the content if you want to make a private one. But make sure you are in accordance with their license. So yeah, I think that is almost the last slide. Yeah. So in this slide, I gave the example. So in 2 weeks, we'll go through essentially this Python dev tips. So you can try forking this repository, because that's the one we'll essentially be looking at in the Python workshop in 2 weeks. That should give you an idea of how to fork a repo with the one that we'll be using in 2 weeks. So in summary, GitHub provides a platform to host and also discuss code, as we saw with the pull requests. And there's also the issues option, which we didn't take a look at. To kind of repeat some of the terminology. So we branch to prototype ideas without breaking or losing stable code, because maybe you delete some stuff, change some stuff. Issues to keep track of bugs and ideas. And pull requests to simultaneously track and incorporate any changes in the code. So you can do that for multiple features at the same time. Let me show issues really quick, since we didn't really see that. But for example, so you can't do issues on a fork. You have to go to the main one. So here you'd create new issues, and you really can just type whatever you want. Change interaction, for example. Would be nice to have questions. So you can really put whatever you want here. But then what's nice is that when you make an issue, everything, the PRs and the issue, they all have a unique number. So then in the PR, you can then reference that issue. For example, let's say I wanted to reference that issue to say, okay, related to number 6. And you can make this link between issues and pull requests. And add the comment there. So then if you click on it, it'll make a hyperlink to that issue. And yeah, that's it for the slides. And interesting timing. But yeah, I hope you enjoyed it. If you have any questions, let me know now. I think pizza should be arriving soon. Can you open for her this way? Thanks. Maybe she's, yeah, I guess the guy will come up now. You can open from that side without the card. Yeah.
We're not working with ESO, but we're working with something else.
Yeah.
To commit, in that case, we have to go through CMD, I guess.
It depends. A lot of IDs, they have their own source control built into it. So I can't answer for all of them. I think PyCharm has. Yeah.
Let's say I'm looking at
Yeah.
I guess I'll have to commit through CMD or there's extension.
I think they're, because IntelliJ, I think is it also from JetBrains IntelliJ? So I'm sure there's probably some source control as well too. So maybe if you Google IntelliJ source control, that would help. Yeah.
So I still didn't quite understand what a pull request is. I know that you make a new branch.
Yeah.
You implement a new feature. Then you publish the branch. But then you automatically create a pull request.
You don't have to make one. So the point of the pull request is to visualize the changes between a branch, a fork, and the main code. Or you can make the comparison between any 2 files.
Okay.
So
add a comment to the whole repo. I implement this feature.
it's to sort of help the process of merging code, because you can merge through the command line, but then you may get all these conflicts. But what the pull request lets you do, I'll just close here. What the pull request lets you do is to visualize this and also discuss the code, because you can't really discuss when you're doing your merge locally. Like those are all just things you're running on your laptop.
Merge conflicts without pull request.
Yeah, you can definitely merge a branch into a main without a pull request.
This is just add this whole like comment section and this.
Yeah, so it's because the pull request is not something in the Git protocol. This is something that GitHub added through their platform to help you with merges. Because the underlying command there is, let's say you're in the branch, let's say you're in your main branch, and you had this dev branch. To do the pull request or to the merge would be the command line argument would be git merge dev when you're inside main. That would merge. And that's the command that's essentially being run when you say merge from GitHub. They're doing these merge commands.
Okay. And why did they not call it like merge suggestion or something?
I have no idea. I mean, even with issues, I don't know why they call it issues necessarily. But now it's stuck. So yeah. Yeah.
I have a question of understanding for when do you need to rebase or what are different like merging strategies?
Mm.
Can you like yeah, because sometimes if you're like certain commits behind or in front of the main,
Yeah.
is it required to rebase or what are other solutions to that?
So there's preemptive solutions to it where I guess the one is, as I was suggesting, always keeping a main branch and the one you're actually working in, so that you just keep that main branch synchronized with whatever other changes are coming in, and then merging it every now and then frequently with where you're actually working. Because then this problem you get with rebasing is those are a bit tricky. Those are the type of stuff that I have to Google to check on how to resolve them, because they're the commands you want to avoid, and typically you avoid them if you've kept things synchronized well. But yeah, I guess you have to do this rebasing stuff when you get into the situation where you're not just behind, but you're also ahead of the main branch, as you were saying. So yeah, then you need a lot of manual things to. It's very case dependent to solve it.
So it's always good to like whenever I commit something, I first like synchronize from the main. Or
So I guess what I would say